Assalamualaikum and hello everyone. Today we are going to do the revision STPM SEM 1 in topic heat transfer. Subtopic is about conduction and radiation. This is the question from STPM SEM 1 2019 in section C number 20. Okay, look at this question. Two rods, a copper and aluminium of equal length and cross-sectional area are joined together and perfectly insulated as shown in diagram below. The temperature at the open end of the copper and aluminium are 80 degrees Celsius and 30 degrees Celsius respectively. Thermal conductivity for copper is 401 watt per meter per degree Celsius and thermal conductivity for aluminium is 235 watt per meter per degree Celsius. Answer number 1. Describe the heat transfer mechanism in the copper rod. Okay, copper rod has the free electron. Okay, copper rod is metal. Okay, so the answer. Initially, atoms in the metal are vibrating about their equilibrium position. When the temperature of one end of the rod increases, atoms begin to vibrate with greater amplitude. Then, this atom collide with their neighboring atom and transfer some of their energy. Because copper has free electron, so collision of free electron with the atom increase the diffusion of free electron from hot end to cool end. Okay, for question number 2, calculate the temperature at the interface of two rods. Okay, interface of two rods, so you want to calculate temperature here. As we know, when the two rods reach the steady state, so rate of heat transfer for the two rods become equal. So rate of heat transfer is dq over dt equal to negative Ka d theta over dx. So we can write that d theta dq over dt for copper equal to dq over dt for aluminium. So we can write that like this. Negative Ka d theta over dx equal to negative Ka d theta over dx for aluminium. And we substitute for copper. Okay, thermal conductivity for copper is 401 watt per meter per degree Celsius. Okay, and area from this statement. Okay, it said that two rod copper a copper and aluminium of equal length and cross-sectional area. So that's mean cross-sectional area we can write as A. Okay, A, and length is L for both value for copper and aluminium. So for copper we write A and length is L, and for aluminium also we write A and length L. Okay, for aluminium we write the thermal conductivity for aluminium is 235. Okay, 235. And for d theta is the temperature different. Okay, temperature different for copper. Okay, so we want to find the temperature, the final temperature. Okay, final temperature minus initial temperature. So for copper, okay, final temperature is theta. So we can write theta minus 80. So theta minus 80. And for aluminium, final temperature minus initial temperature, and final temperature is 30 degree and initial temperature is theta. So we can write final temperature 30 minus theta. Okay. Okay, because these two rods have equal length and equal cross-sectional area, so we can cancel it out. So we get the equation like this, and we calculate until we get the temperature at the interface of two rods is 61.5 degrees Celsius. And we can also check it out whether it is true or not by look at this figure. That's mean temperature at the interface between two rods must be between 80 degrees Celsius and 30 degrees Celsius. So we get temperature equal to 61.5. So the value for temperature is correct.
An isolated object with a surface area of 3 meters square, temperature 25 degrees Celsius, and emissivity of the surface is 0.80, placed in an environment of 75 degrees Celsius for 50 seconds. Okay, first state the factor which affect the amount of energy radiated by the object. Okay, as we know that as we know that heat per unit time, heat per unit time equal E sigma A4. So from this equation we can list down the factor which affect the amount of energy radiated by the object by looking at this equation, which is the factor is E and the surface area and temperature. So the answer is temperature, surface area, and nature or type of surface. Okay, look at question number 2. Determine the net rate of energy exchange of the object. Okay, net rate of energy exchange of the object. From the statement here, we know that temperature for object 5 degrees Celsius and temperature is 75 degrees Celsius. So that's mean temperature environment or temperature surrounding is bigger than temperature object. So rate of energy is absorbed from surrounding. Okay, so net rate of energy exchange. Okay, as we know that net rate of energy exchange is P equal to E sigma A T power of 4. Okay, P is also equal with Q over T. Okay, rate of energy exchange. So we can calculate, okay, by using this equation. And for temperature is temperature exchange, okay, temperature different, so equal to temperature environment minus temperature object. Okay, we must make sure that unit for temperature must be in Kelvin. Okay, so firstly we change the temperature in degrees Celsius, change it to Kelvin by plus the temperature by 273 to get the temperature in Kelvin. And we can substitute the value, okay, the value for this equation, that is E is emissivity of the surface 0.8. Okay, sigma is Stefan Boltzmann constant 5.67 times 10 to the power of negative 8. Area, okay, area is meter square, and temperature environment, okay, 348 power of 4 minus 298 power of 4. And we get the answer is 9.23 times 10 to the power of 2 watt. Okay, for number 3, determine the net energy absorbed by the object. Net energy absorbed. Okay, from B, we get the rate of energy change. Okay, rate of energy change is Q over T. So, net energy absorbed is Q. Q equal to PT. So, we substitute, okay, P here. So, we get the answer 923 times 50 is equal to 4.61 times 10 to the power of 6 joule. Okay, that's all. Thank you.